Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ashraf bin Muhammad Nasri. I am from Group 4, Section 2 for Electronic Engineering Lab 2, Power System Lab. So, good morning to Dr. Raida binti Makir. So, for this lab is PS1a overhead line model. So, our group consists of four: Luis, along Ashraf, and me, Ashraf, and Muhammad Daniel. Okay, so for the abstract, the calculation of parameters is an essential task in electrical power engineering for the efficient and reliable operation of power systems. One of the most prominent tools for this computation is the MATLAB program. It provides a variety of mathematical model and simulation approaches that enable engineers to precisely predict line characteristics, including resistance, inductance, and capacitance. Line parameters are transmission line properties such as resistance, inductance, and capacitance that govern how the line behaves under different operating situations. These characteristics are computed using mathematical models and simulation approaches, which can be sophisticated and time-consuming. However, accurate line parameter determination is critical for the efficient and reliable operation of power systems because it allows for the prediction and correction of power losses, voltage drops, and other performance issues. This abstract offers an overview of the process and tools utilized in MATLAB software to compute line parameters, the usage of matrices, circuit models, and numerical approaches such as finite element method and the boundary element method are also discussed. So for the for the aim to figure out the positive sequence line parameters L and C per phase per kilometer of three-phase single and double circuit transmission lines for various conductor layout, as well as to comprehend medium line modeling and performance. So for the introduction, a transmission line for electrical characteristic resistance, inductance, capacitance, and conductance. Inductance and capacitance are caused by interaction of magnetic and electric fields surrounding the wire. The shunt conductance characterize the insignificant leakage current via insulators, which may be ignored. The parameters R, L, and C are needed to create gearbox line models for use in power system analysis during both the planning and operational stage, while the conductor resistivity can be determined based on the manufacturer's data. Inductance and capacitance can be calculated using a formula. The flux linkage per ampere is used to compute inductance if the conductors on the three-phase line are not spaced equilaterally. The inductance of each phase is not equal. The unbalanced circuit is caused by different inductance in each phase. The inductance of the phases and the conductors are transposed, and the average inductance per phase is computed using basic procedures that vary based on conductor design. Okay, so next, I will pass to my team members to explain about method. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz bin Sulaiman, DE210044. Okay, I will continue for the lab report for the method. So, for the first is do the MATLAB simulation based on the given code. Okay, so the first thing is open the MATLAB, create a new editor and insert the exercise 1 coding into the editor. And then you need to click the save button and save it as lab 1. After that, click run and the output will be shown in the command window. Okay, this is the command window. Okay, after that, insert the value for the DAB, DBC, DAC inside the D here, and then use the equation for GMRL equal to GMR divided by 12, and then enter. After that, you will see the command window will show the result of inductors and also the capacitance. Okay, for the question 2 also quite the same. Just put the coding inside the editor save it as lab power 2 and then click run at here and see at the command window. You can see you will need to enter the value for DAB, DABC, DAC, conductor diameter, bar spacing, and also the GMR value, and you will get for the inductors and the capacitance. After that, question 3 also the same. Insert the coding and then run the coding. So you need to insert the value for the raw vector, bar spacing, conductor diameter, also GMR. Then you will need to hit the enter and the result will shown just like this. After you get the answer, you need to compare with the MATLAB result with the manual calculation. So this is for the manual calculation. You can see here question 1 until question 3. Okay, that's all for me. Thank you.
Hi everyone, and doctor, and my name is Luis Gangshen, and metric number CE 210002. So today I will explain about the exercise 1, exercise 2, and exercise 3. And we need to, based on the question, put inside the value. So the program coding is given. So we need to put inside the coding into the MATLAB so we can run the program. But before that, we need to study about the exercise question 1, 2, and 3. So now I proceed to the MATLAB because the program already given here, the coding is already given here. So I proceed to the MATLAB. So this one is the coding of the program 1. And after we put inside the coding, and then we run the circuit, we need to put the value of AB, but we need to refer to the question just now. So the program 1, the AB value is 35, BC is 35, and then AC is 70, and then the GMRL value in each is 0.0444, and then it come out the result of L is 1.3802. And then we need to key in the conductor in the meter in each. So this one is 1.345. So we will get the answer of capacitor of 0.0083. So this one is for program 1. And then we proceed to program 2. Program 2 as well, we need to refer to the question and the manual solution given by the lab sheet. So I put inside the coding. So let's go that we run this coding, and then it requires us to put inside the DAV value. So the DAV value is D35, and then BC is 35 also, and then AC is 70, and then conductor diameter in each is 0.977. Later on, its bundle spacing in each is 80, and then the GMR in each is 0.3924. That it will show the L is 1.0588, and then C is 0.107. Next, we proceed to the quadrant 3. Let us clear the command window first. Then we also put in the coding from the lab sheet, but this one we found some error, then we change a bit of the coding here. So then we run the circuit. Then it requires us to put inside a vector number. So this one is 11, 16.5, 12.5. And row vector h12 and h23 is 7, 6.5. Next is bundle spacing in each 18. Conductor diameter in each is 1.427. And then the geometry mean radius in each is 0.564. Then we will get the L and C value, and then also the GMD 11.2135, GMRL 1.1873, GMRC 1.2592, L is 0.4491, and C is 0.0254. All these three programs, program 3, program 2, and program 1, the answer is same with the map sheet. So we be successful for this map. Next, I will explain about the discussion. So discussion that we learn from this map is we learn how to conduct the map by using the map and also how to edit the coding so that we can match the result in the map sheet in the manual calculation between MATLAB and the manual calculation. In this step, we also found some problem in coding tree. So just now, I mentioned that we changed a bit of the coding so that it will come up the correct value compared to the manual calculation. And each of the program is related to each of the questions. So program 1 is related to question 1. Program 2 is related to question 2, and then program 3 is related to question 3. So we need to take note the unit. For example, each feet at km. So we need to notice that if not, we give the wrong value, the final answer will be wrong, and then the result will be not matched. So if we key in the wrong value, it will affect the result, and then the program, and it will not match with the manual calculation. That's all from me. Thank you.
In conclusion, we learn how to use MATLAB to run experiments and adjust the code for accurate result. We need to input values with the correct units to avoid mistakes. We had some troubles with 3 programs, but we fixed it and got the desired outcomes. To succeed in MATLAB experiments, we need to be careful and pay attention to detail when writing the codes.